Welcome to The Explainer, where we break down big topics by going straight to the source material. Today, we're digging into one of the most mind-bending fields in tech, brain-computer interfaces.
So, let's just jump right in with the big one, right? Can technology literally read your thoughts? I mean, it's a question that feels like it's pulled straight from a sci-fi movie, but with companies like Neuralink all over the news, you have to wonder, how close are we really?
Okay, so first things first, we gotta get something straight. That term, mind reading, is really misleading. It makes you picture some machine that can just tap into your consciousness and see your memories, your secrets, the whole shebang. The reality, though, is a bit more grounded in, well, in biology. Here's the deal. Every single time you have a thought or make a decision, your brain cells fire off in these specific patterns, creating these tiny little electrical signals. Now, a BCI doesn't know the feeling of your thought. It can't feel your happiness or your anger, but it can learn to recognize that electrical signature. It's like reading the footprint left in the sand, not reading the person who made it.
So if they aren't actually reading our minds, what exactly are they doing? How do these things manage to build a bridge between the world inside your head and an actual machine out here in the real world?
You can kind of think of a BCI as a universal translator for your brain. It's listening in on all that complex electrical chatter, figures out what it means, and then translates it into a simple command that a machine can understand. It's basically building a brand new highway for communication that completely skips the body's usual routes, our nerves and muscles.
Now, when it comes to how this is done, there are basically two main flavors, and they come with a huge trade-off. On one side, you have invasive BCIs. This is where they surgically implant tiny electrodes right into the brain tissue. The result? You get these incredibly clean, high-quality signals. On the other side, you've got non-invasive methods, like an EEG cap that just has sensors on your scalp. It's way safer, obviously, but your skull kind of acts like a filter, so the signals that get through are weaker, more muffled. It's this constant balancing act between getting a clear signal and taking a big risk.
And this stuff didn't just pop up out of nowhere. It's standing on the shoulders of almost 100 years of research. It all started back in the 1920s with the very first recordings of human brainwaves. From there, it was just this steady march of progress, coining the actual term brain-computer interface in the 70s, the first brave patients getting implants in the 90s, all leading to these incredible moments, like when Matt Nagel was able to move a computer cursor just by thinking about it.
So, all that progress has led to some genuinely life-altering applications in medicine. But, and this is a big but, with every miracle there's been a ton of hype, and in some cases, some pretty serious misrepresentations about what this technology can actually pull off.
I mean, in the medical world, the results they're just incredible. We're talking about people with paralysis being able to control a robotic arm so well they can feed themselves. Patients who couldn't speak a single word are now able to communicate just by thinking. We've even seen early vision implants let a blind man see patterns of light, enough to slowly drive a car around. This isn't a promise for the future. This is happening today.
So how does something that amazing, like controlling a robotic arm, actually happen? Well, it really boils down to a three-step dance. First, you just think about moving your arm, and the electrodes pick up that unique brain pattern. Second, a computer algorithm acts as that translator we talked about, turning that messy brain signal into a clean, simple command. And finally, that command gets sent to the robot and it moves. It's a direct line from intention to action.
But this is where the hype machine can really get ahead of the actual science. You might see a headline about scientists decoding dreams, right? It sounds like they're just recording a movie from someone's head. But what those stories often leave out is the absolutely painstaking work behind it. In this case, it took 30 to 45 hours of interviews for each person just to train the system to recognize a few specific objects they dreamt about. And you see this kind of over-the-top claim even more in the consumer market. You see a headset that says you can control a video game with your mind. Well, chances are it's not actually reading your brainwaves. It's probably just picking up on the tiny, unconscious electrical signals from your facial muscles when you say clench your jaw or raise your eyebrows. And those muscle signals are way stronger and way easier to detect than the super subtle signals coming from your brain.
And all of this leads us to what might be the single most important question in this whole conversation. As this technology gets better and better, what happens to what is probably the most personal data that could ever exist, the raw data from inside our own minds?
Because we are walking right into a massive ethical minefield here. I mean, these are questions that used to be for philosophers, and now they're for engineers. Who gets to see your neural data? Could you get in trouble for just thinking about something? even if you never do it? Could advertisers or political campaigns create a neuroprofile of you to figure out your deepest biases and manipulate you without you even realizing it?
And just think about the chilling effect of that for a second. If you knew, for sure, that your thoughts could be watched, would you still let yourself think freely? Would you still explore controversial ideas? Or even just question your own beliefs? The simple fear of being monitored could fundamentally change the way we think. It's a profound thought.
And listen, this isn't some far-off sci-fi what-if scenario. This has already been done in a lab. Researchers focused on a specific brain signal our brains produce. It's called the P300 wave that kind of lights up whenever we recognize something important. So while people were playing a game, the researchers flashed a bunch of images at them, including numbers. By watching for that P300 wave, they were able to correctly guess private information, like a person's bank PIN, all without the person having any idea they were giving away their secrets.
So, okay, you've got these unbelievable promises on one hand and these really, really scary dangers on the other. Where does this all go from here? What's the end game beyond helping patients?
Well, if you look online, you can see the public imagination is already running wild with it. A lot of people see BCIs as the next logical step after the smartphone. I mean, why bother typing or talking when you can just think? This idea of technological telepathy, of sending thoughts and even feelings directly from your brain to someone else's, it's a really powerful vision.
But that vision creates this fundamental tension, right? You can see it right here. On one side, there's all this excitement for the ultimate convenience, this seamless fusion of human and machine. And on the other side, you have the experts, the neuroscientists and ethicists, who are raising some very loud alarm bells about what we might be giving up in the process, our privacy, our freedom of thought, maybe even a little piece of what makes us who we are.
And that leaves us with the ultimate question, the one we all have to start grappling with. As this technology shifts from just fixing problems to actually enhancing healthy humans, who gets to write the rules for our own minds? We're on the brink of needing a whole new set of human rights, not just for our bodies, but for our consciousness itself. And that is a conversation we need to be having, like, right now.